In this problem, we're asked to consider the area between the curves x equals negative y and x equals 2 minus y squared. And I know that I am more comfortable considering these in terms of y, so I'm going to solve for y in both cases. So this is what the functions are when they're solved for y as opposed to x. And that just helps me with regards to having the picture correct. Just that form is a little easier for me to think about. So we have y equals negative x. We have the positive root of 2 minus x and the negative root of 2 minus x. So make sure you're clear on why the graph would look this way. We want to find this area here, and so we'll need to know this point of intersection, this point of intersection. And then we'll be able to discuss why having it in the form of y is cleaner, although I needed to put it solve for y. It was easier for me in terms of the graph. So let's find these points of intersection using your calculator, or however you choose to. You should find that this point of intersection is negative 2, 2, and this point of intersection is 1, negative 1. Now, because for our graph we had to put these in, solve them for y in terms of x, and 1 if we're going to use our graphing calculator to graph it, 2 just to get a cleaner understanding to what we're used to. If we were to leave it solved for x, then we would need to consider this portion. This involves the positive root of 2 minus x and negative x, get an integral, and we would need to consider this portion here separately. But this thing's a lot nicer if we consider it in terms of y, because in terms of y we just have two graphs bounded by 2 minus y squared here and bounded by negative y here. So if we consider it in that sense, the area would be the integral from negative 1 to 2, because in terms of y it starts at negative 1, that's the bottom, and goes up to 2. And when we were orienting everything in terms of x, it was always the top curve minus the bottom curve. In terms of y, it will be the rightmost curve minus the leftmost curve. So in this case, over the entire interval, 2 minus y squared is on the right, and we will subtract negative y, because it's the leftmost curve, dy. And you can do a few different things with this. This one's actually not too bad to do by hand because it's a polynomial, right? From negative 1 to 2 of negative y squared plus y plus 2 dy. 1 to 2. And when you integrate that, you'll have, what will that be? Negative 1/3 y cubed plus 1/2 y squared plus 2y from negative 1 to 2. And when we substitute and simplify, you will find that the area of this curve is, you'll find that it ends up being 9 1/2.